Hey there everyone, today we're doing 7.3.1 on hyperbola. This is our third and final conic that we'll be learning in chapter 7. In this section we're going to learn how to analyze and graph hyperbola. Hyperbola are very similar to ellipses. They are still a locus of points, and they still require 2 points, just like an ellipse required the 2 foci. Our 2 foci here in a hyperbola, however, we're not going to find the summative difference, or the summation of the distances. We're going to actually find the difference of the distances. So instead of adding the distances together and making sure we find all the points where their distances added up are the same, we're finding all the points where the difference between the 2 distances are the same. So you're just subtracting instead of adding like you were for ellipses. In hyperbola, we actually have a couple of new vocabulary words. We have the transverse axis, and the transverse axis is what used to be our major axis, but it continues on forever and ever. The major axis stopped at the vertex in an ellipse. Here the transverse axis keeps going, just like our hyperbola keep going. And the transverse axis goes through the foci, through the center, and through the vertices. And it acts as a line of symmetry as well. Our conjugate axis does not cross through the foci or the vertex. It just goes through the center, and it still acts as a line of symmetry as well. Okay, you can remember transverse goes across all of the points because the word trans means across. All right, if we look at our general form, or our standard forms for the equations of hyperbola, it's very similar to ellipses. You'll notice that everything is the same except for instead of adding, we are subtracting. You'll also notice that for horizontal ellipses, that A and B don't switch. In hyperbola, A and B aren't necessarily designated by whichever one's bigger. They are specific to their location. So A squared always goes into the first one, and B squared always goes into the second one. If you're changing the orientation of the hyperbola, then you change the orientation of the x minus h squared and the y minus k squared. Okay, so with ellipses we would just switch a squared and b squared. With hyperbola we actually switch x minus h squared and y minus k squared, depending on whether we're vertical or horizontal. So if x minus h squared is first, it's going to be a horizontal transverse axis. So your transverse axis will go across, just like you would have a horizontal ellipse. Your center is still going to be hk, and your vertices are still going to be a distance away from the center. So we're still measuring our vertices and our foci from the center, just like we were for ellipses. So not a whole lot is different there. Instead of calling it the major axis, it's called the transverse axis. That'll be at y is equal to k. And your conjugate axis is going to be at x equals h. So again, we're just finding those lines that go through the center of the hyperbola. And then we're going to have these asymptotes. These asymptotes are really useful for sketching the graphs. These are not parabola, and so we can't use the same principle. We don't have a directrix to help us graph the hyperbola here. Instead, we're going to use these asymptotes. And this should be familiar to you. This is basically point-slope formula. Notice that the point that these asymptotes go through, they always go through the center. So the point that they plugged in was the center, h and k. And then the slope of the lines, that can be found by doing b over a. So b over a is really going to tell us the slope of the asymptotes that go through the center of the hyperbola. For the vertical hyperbola, it's pretty much the same exact thing. The only thing is that you're going to be adding a and c to find the focus and the vertex to your y coordinates. So you're going to add and subtract those from k. And of course your transverse axis and your conjugate axis are reversed. So your transverse axis is going up and down and your conjugate axis is going left and right. But your asymptotes are pretty much exactly the same. Notice there's no change in the formula for the asymptotes. And in both cases, we have to reorder our a squared, b squared, and c squared. For ellipses, a was always your longest side. That's not true in hyperbola. In fact, c is always going to be your longest side for hyperbola because we move the focus outside of the vertices. So now a is smaller than c. So c takes over as being our hypotenuse, and so the equation goes back to being our traditional a squared plus b squared equals c squared for hyperbola. Alright, enough talking, let's do some math. We're going to go ahead and graph this hyperbola. The first ones are going to start off really easy because they're going to always give you the center at 0, 0. Most of the problems that we do in class tomorrow will start with the center at 0, 0. But after this example, I'm going to show you one where the center is not 0, 0. So I'll go ahead and set up my axis. It's really easy to identify h and k here. H is whatever you're subtracting or adding from the binomial with x, and that's going to be 0, since there's nothing there. And with y, it's going to be 0. So our center is very easily noted at 0, 0. Okay. Now, the center is not part of the graph, just like it wasn't part of the ellipse, but that is going to help me find out where my vertices are, because that's really the most important thing. So notice that A is always first now. So A is no longer the big length. A is just whichever one comes first. So A squared is equal to 9, which means A is equal to 3. And B squared is equal to 25, which means B is equal to 5. A and B are both important because they're going to help us find the slope of those asymptotic lines. So since A is 3, I need to decide if this is going to be a vertical hyperbola or if this is going to be a horizontal hyperbola. And because y squared comes first, we can tell that it's going to be vertical. So I know if I go 3 units vertically, 1, 2, 3, that's going to tell me the location of the vertex for my first half of the hyperbola. And then if I go down 3, that's going to tell me the other vertex for the hyperbola. Okay. We know that the asymptotes are going to go through the center of the point that we picked. Now we just need to figure out the slope of the line. So the equation for the asymptotes is y minus k equals plus or minus a over b times x minus h. Okay, remember this is the slope for vertical. For horizontal, it would be b over a. So we're going to go ahead and plug in a and b to see that the slope is going to be plus or minus 3/5. We can plug in the center to get the actual equation of the line. The center is 0, 0, so it's going to be x here and just a y here. So we get a really easy line to graph. It's just y equals 3/5 of x and y equals negative 3/5 x. So we can go ahead and graph the asymptotes next. We'll do those in red. So I rise 3, that's where my vertex is, and I run 5. 1, 2, 3, 4, 5. That gives me another point on my line. So we fall 3 and go 1, 2, 3, 4, 5 this way. And now we can draw our asymptote. Okay, there we go. That's one of them, and the plus or minus actually shows us that there are 2 asymptotes, one going with a positive slope of 3/5 and one going with a negative slope of 3/5. So if I go negative 3 and over 5, that's going to give me my other asymptote. Alright, now that we have our asymptotes, we can go ahead and sketch our hyperbola. The vertex is right here. We'll go ahead and sketch in that we have hyperbola going like this. And hyperbola going like this. Okay. Let's try one that is not centered at 0, 0, because it gets a little more complex when we do that. Okay, for B here, this time our center is off of the origin. If we look at the equation, it's pretty easy to see that the center is going to be at -1, -2. A always comes first, so A is going to equal, well, A squared I'll say is equal to 9, so that means A is equal to 3. B squared is equal to 16, so that means B is equal to 4. And this time we're going to have a horizontal hyperbola. So that means the equations for my asymptotes are going to be y minus k equals plus or minus b over a times x minus h. And so we can write the equations of the lines just by plugging in k, h, b, and a. So it's going to be y plus 2 equals plus or minus 4/3 x plus 1. Alright, let's go ahead and graph this bad boy. Center is at -1, -2, so I'll plot that point first. And this is a horizontal, so when I find out that my distance A is 3, I go 3 units to the right, 1, 2, 3, and 3 units to the left, 1, 2, 3. And you have a couple of options. You could solve this equation for y, and then graph those two lines as you've learned to graph lines before. Or since we know that the lines go through the center, which I've already labeled right here as the center, and these are my vertices, you could just use this point and the slope to find some more points on your asymptotes, which is what I prefer to do. So since my slope I see is 4/3, I can start at the center and go up 4, 1, 2, 3, 4, and over 3, 1, 2, 3. And do that a couple times to keep your line going. And in the other direction. There's our first asymptote. And then we'll do the same thing, but in the negative direction. So one there, one there, one there, one there. Okay, now that you have your asymptotes drawn in, and we have our vertices, we're ready to sketch our hyperbola. Just make sure that the hyperbola does not cross the asymptotes, but rather approaches them. Should look like it's getting closer and closer to those asymptotes as it goes out. Okay, and so there's your example of a horizontal hyperbola that is not centered at the origin. So always start by finding your center first and then base everything off of that point. When you're graphing these, you don't have to find the focus. You will be given the focus in other examples, and you'll use that to find A and B. So here are two more hyperbola you can try on your own. These are both fairly simple. Don't worry about B. This one you'd actually get some decimal answers, and so you'd have to kind of approximate it. So don't worry about graphing B. Just graph 1A. It's fairly simple, and it has its center at the origin. Okay, here's your graph for the hyperbola, and the only thing I do want you to write down is I always want you to write the center down. Plot the vertices, plot the asymptotes, and then write the equation of the asymptotes. So that should always be written as part of your solution for the hyperbola problems. You don't really need any other points as long as you have the asymptotes in there and the vertices. I trust that you'll sketch a curve that's at least looking like it's approaching the asymptotes. Okay? That's it for the lesson today. We will continue exploring hyperbolas next time.